Okay, class, this is going to be my little demonstration for lab number 6 called paper chromatography. And I'm just going to start off by showing you the materials that you will need. Of course, we always start with safety equipment first. So be sure you have your safety glasses, goggles, and also gloves on for this lab as you would for any other lab, just to be safe. And then here I have on the counter the materials that you'll be needing for the first couple parts, and then also for the last couple parts. We're going to go through those separately. But you'll need graduated cylinder, scissors, a ruler, pencil, beaker, your filter paper, stirring rod, and a little paper clip like this. And then your solvents, we're going to have water, we'll have acetone, and then alcohol. You'll use 2 out of those 3. Well, water and then either acetone or alcohol. And then you'll need 4 different pens. I've got a series out here laid out as examples. We're going to be using these bottom 4. This is a Sharpie. This is a dry erase ink. This is a gel pen, and then this is just for variety. I put in here a red Uniball pen. So we're going to use those 4 to conduct this experiment on chromatography. So that should be pretty much material that you'll need. And now we'll go through the different parts of the lab. Okay, so let's do the first 2 steps in your procedure. The first one will be preparing the chromatogram, or the paper that you'll be using for this experiment. And the second step will be adding the ink to the paper. And so there's some dimensions in your lab procedure which I want you to follow, but what I want you to use is one of your circular filter papers that come with your kit, one of these, and then you're going to cut it in a rectangular shape like this. And it's going to be 5 centimeters wide by 8 centimeters tall. You're going to cut this rectangularly, and I think you can see this. We're going to draw a pencil line, use pencil only, pencil, about 1.5 centimeters from the bottom, so be sure you distinguish the bottom from the top. I have B for bottom, T for top on here marked just so I know. And then you're going to draw another line from the bottom about 1 centimeter from the top. 1.5 centimeters from the bottom, pencil line, 1 centimeter from the top, another pencil line. Then you're going to make 4 marks on the bottom half where you're going to dot your paper. So 1, 2, 3, 4, and they're just like little crosshairs so that you know where to dot your paper. So once you get this cut and you get it marked with pencil, then we're going to spot it at the marks with the different pens, and I will show you how to do that as well. So put the paper down on a flat surface and then just take one of your markers. This is going to be the Sharpie, and we're going to just touch it. So just to form a small dot right at the first X, and I'll show you this. Just touch it right at that first X so that there's a black dot. Not a large dot, I'll show you. So it doesn't have to be small. So it's just very small dot. Make sure you can see that. So it's not big at all. Right at the first X mark, and then we're going to do the same thing for the other 3 pens that we've decided to use. This one is the dry erase, so that's going to be number 2. I'm going to touch it, just maybe 3 or 4 times depending on how quickly it comes out of your pen. And you can use whatever pens you have in the house just to see the difference. This is our gel pen. That's blue, and it's going to mark that one. Actually, it's a light blue. So we're going to mark the 3rd dot with that one. And then the 4th dot, I'm just taking a red Uniball, just for variety, a different color. And we're going to mark that at the fourth. Just tap it 3 or 4 times. You get a nice dot. Not too big. And then you will see when you're finished, your chromatogram should look something like this. And the dots are on the bottom line. It is 1.5 centimeters from the bottom of your paper. Okay, so that's pretty straightforward is how do you prepare your chromatogram. Now, our first solvent we're going to use, I'm just going to use water, but it says to you, you're going to do this twice. You're going to use once for water, and then you either use acetone, which I've got a bottle here, nail polish remover, that's acetone, or you can also use alcohol as your other solvent. So let us just use our water first. And what you want to do is get about 15 mils of water in a beaker like this. You're not going to use very much. And I want you to measure exactly 25 mils of water into a graduated cylinder. Don't use any more than that. That's just about the level that you want, and I'll explain why later. So just measure about 25 mils of water. That's a little too much, so we'll pour a little out. Okay, perfect. So that's 25 mils. Next couple steps. So after we get the chromatogram, then we're going to develop our chromatogram in our beaker with our solvent. So this is step 3, developing the chromatogram using water as the solvent. So we're going to take 25 mils of water, and we have our 250 ml beaker, and we're going to add the water to the beaker, like that. Then we're going to take our chromatogram paper that we prepared in the first couple steps, and we've got this little clip that works out nicely. This little black clip, you've all seen these kind. And we're going to clip the top to the 1 centimeter mark, like that. Okay, so you can see that. Then we're going to take our glass stirring rod, and it just fits nicely through the clip. All right, so then it looks like this. Now we're ready to put our chromatogram paper into the beaker. And once you put it in, you don't want to take it out. You want to leave it in until, in this case, water, the solvent has traveled up to the top pencil line. Okay, and you want to be sure that you don't touch the sides of the beaker, that it's freestanding in the solvent, because the next time you're going to do this is going to be with alcohol, with acetone. So then we just put this in the beaker. So it doesn't touch the. And then we're going to just let it develop as the water travels up. And you'll see that once it touches the paper, the water starts to move up, and then it's going to touch the different dots that you use for your ink. And then you should see separation of the dots as it goes up. And what you're going to do is let this travel up the filter paper, and be sure you don't leave it in too long so it goes past the end, but you're going to leave it in until it gets up to the top, and then you're going to measure the separation of the inks in the various dots. So we'll let that develop for a few minutes, and we'll come back. Okay, class, we're back. I just wanted to show you how this is coming along, the demonstration of this chromatogram. You can see how the chromatogram is developing, and the one ink on the left is not moving at all. That's because it's the permanent marker, so it's not soluble in the water. The next one is the wet dry erase pen. So it is soluble in water, it's moving nicely up the paper. The third one is the gel, so it's kind of a mixture of both. And the fourth one is the red pen, the Uniball is what it's called. And so it's kind of both. So this just illustrates the solubilities of the different pens in the mobile phase, which is in this case water. And we're going to let this go until the solvent stops, until it reaches that top pencil line. And then we'll use this to use a ruler to measure the RF values, which are also explained. And we'll talk about that in class as well. So once you start, you should just leave the beaker as it is. Don't touch it or don't move it. You want the solvent to go up uniformly. So you just wait. And this has been 10 minutes so far, so we'll give it another 5 or 10 minutes until it reaches the top. We'll see how far the solvent goes. And then next we'll try it with acetone. So we'll let it develop a few more minutes. Okay, class, we're back. And I can see that the solvent has reached the top line, our top pencil line. So now I can remove the paper from the solvent, and we're going to let it dry. And if you can look at the observations that we make already, our number 1 is the permanent Sharpie. Our number 2 is the dry erase marker. You can see, interestingly, we have 2 different colors. We have purple and we have blue. So there actually could be 2 RF values, 2 different compounds in that marker. And then the third one, which is the gel, is kind of a one color, and it's not really a dot, but we measure the RF value from the top, and it actually is a little bit different RF value than number 2. Number 3 is just one color. And then the last one is the red ink, red pen, and we measure RF value essentially at the top where the color stops, and it's no longer at the top. Where the RF value is defined as the distance the solvent traveled from the top to the that's in the denominator, and then in the numerator we have the distance that the color traveled for each separate ink. Okay, so that's what my chromatogram looks like, and now we're going to prepare another paper, another chromatogram paper with dots, and we're going to try a different solvent, and we can compare how the two separate with the different solvents. So we'll be back with the acetone. Okay, class, I'm back, and I have prepared my second chromatograph paper. Again, 5 centimeters wide by 8 centimeters tall. The bottom line is 1.5 centimeters from the bottom, and the top line is 1 centimeter from the top. And I put a crosshair 1 centimeter apart on the bottom for each of the 4 inks, and I've labeled them this time 1, 2, 3, 4. That'll be easier for us to talk about the different pens just by number, about the different inks. Okay, so then we're going to lay this flat, and we're going to mark them again, and we're going to mark them the same as you did the first time, in the same order, so you can compare. So the first one will be the Sharpie, and we're going to dot this. We get a nice round dot on the number 1 spot. Okay, that's that one. Then we got the blue dry erase, or vis-a-vis, I guess it's called. I'm going to call that number 2 like we did before. And we'll see. Dot that about 4 or 5 times just to be sure you get a nice dot. Not too much though, don't put too much on, otherwise it'll smear even worse than the first one. So it's hard to get that to separate anyway. And then this one is the gel, so we're going to dot that one a little bit right there. That one comes out pretty smoothly, pretty easy. And then the last one is the red Uniball pen, red pen. We're going to dot that one, so we're going to do a couple little circles. And so now we have our chromatogram ready to go. 1, 2, 3, 4, and you can see the size of the dots. And you just keep tapping the paper, maybe your little circles just to get the dots so you get enough ink on there so that you know that it will travel up with the solvent. Okay, so this time, let's get our beaker ready. We're going to use acetone. So I've got some nail polish remover, which is the same as acetone. We want to use the same amount, so 25 mils. So I'm going to hold this up and I'm going to measure 25 mils into my graduated cylinder. It's right about about 20, and then we add a couple more mils. Okay, that should do it. So we're going to add that to our beaker, our 250 ml beaker, our 25 ml of acetone. Okay. Now we're going to get our clip, attach it to the top of our chromatogram, to just above the pencil line. And then we're going to take our stirring rod, just like we did before. Okay? So now we're ready to add this to our beaker. Make sure you turn it so that it's level. And then once you've added it, you just let it sit. Don't disturb the beaker once it's started to develop. And we'll wait for a few minutes and we'll see what happens and notice the differences in the solvents. Since we're using acetone, it's probably a good idea just to kind of cover it up with something just to eliminate or minimize the evaporation of the acetone that's in your beaker. And we'll see it rise. It goes up the paper, and we'll look for some separation. And then we're going to compare it to the water. So we'll just put that on the top there just to minimize evaporation of the acetone. And then we'll watch and see, and we'll come back in a few minutes and we'll see what kind of separation we get and how this is going to compare to our water as a solvent. Okay, so we'll give that 5 or 10 minutes and we'll come back and we'll look at it. Okay, class, I just thought I'd show you how we're doing so far with the acetone. And you can see there's always significant difference in the two chromatograms. The chromatogram on the right was the one we used water. And I can see that even after we pulled it, we took the paper out of the water, the solvent still kept rising up the paper and went past our line. And that's okay, just as long as it doesn't go clear to the edge, which it looks like it just stopped. So we can see that for number 2, which was the dry erase pen, we actually had 2 compounds. One is kind of a purplish with that is below the darker bluish type color. That's number 2 on the chromatogram on the right. And number 3 also continued to travel up the solvent line past a little bit. You can see that they're not real dots, they're smears, which means I probably could have used a little less ink when I dotted the chromatograms. So what I'm going to do with our new chromatogram on the left with the acetone, which is about halfway developed, I'm going to stop it maybe about halfway or 3/4 of the way before it gets to the top pencil line, because the solvent continues to travel past and I don't want it to go past the edge of the paper. But look at the difference in number 1. So number 1 is our Sharpie permanent marker on the left, number 1, and you see how it is moving with the mobile phase, unlike our first chromatogram on the right with water, where there was nothing moving, nothing soluble in water for the first one, and the acetone clearly has a different effect on number 1. And if you look at the far right, which is our red pen, our Uniball pen, again, the one on the left with the acetone, essentially no solvent, no dissolution or no dissolving of the red ink in the acetone, but it's definitely soluble in the water on our first chromatogram on the right. So we'll talk in class a little bit about the differences in the mobile phase versus the stationary phase and what's actually going on in terms of separation of these compounds. Okay, class, it's been about 15-20 minutes since we've started the acetone chromatogram that's on the left and comparing it to the one with water on the right. And it's still moving, albeit slowly, so we're going to give it a few more minutes and then we'll stop it before it gets to the pencil line at the top. Looks like we're getting pretty good separation for 2 and 3 on the left. Number 4 on the left is the red pen, and so it's showing no solubility in the acetone and not moving with the mobile phase at all. And then the number 1 on the left is our Sharpie, and it is soluble in the acetone and moving up. So we'll be back in a few minutes. Okay, class, we're back, and where we're at. The acetone has really slowed down in terms of moving up the paper, so we're going to give it a couple more minutes. I just want to be sure that we can measure the darkest part of the dots to get our RF value, which is the distance of the dot divided by the distance of the solvent line. So we don't want the solvent line to go past the edge of the paper. So we're going to stop it. It's getting close to that pencil line, so it travels a little bit further once we pull it out, once we take the paper out of the solvent. So I'll give it 5 more minutes and then I'll be back. Okay, class, we're going to stop the acetone experiment and we're going to just lift it out of the solvent. And now we're going to we want the chromatogram paper, both of them, to dry, and then we'll mark them appropriately so we can measure our RF values. So I'm going to put that right there like that, so it's out of the acetone and it can dry. And then this is the one from our water as a solvent. You can tell that the solvent line just stopped right before the edge of the paper, at least I can see on mine here, so we'll be able to measure our RF values. And I'm going to let these dry and then we'll come back and I'll show you how to take those measurements, okay? Okay, class, just to wrap this experiment up, I am going to show you the 2 chromatograms. The one on the left is the one from water, the one on the right is the one with the acetone. And I added numbers here, you can't really see them, but numbered 1, 2, 3, 4, 1, 2, 3, 4 for each one. And now the RF value is defined as the distance the solvent travels all the way up, total distance, divided by the distance of the dot for a particular color or ink that we used. So in our first experiment for water, the solvent line almost reached to the edge, almost to the top, but not quite, so we can still use it as a good value. And so that distance from the baseline to the top of the solvent for the water was 6.35 centimeters. That's our total distance that the solvent traveled for water. And then for an example, if we want to measure the RF value, then there's no RF value for the first one because there's no dots. So number 1, which was the permanent marker, was not soluble in water at all. Number 2 was our vis-a-vis, or our dry erase marker, and it actually has 2 dots, so we actually have 2 RF values. And we'll measure from the center of the darkest area of the dot. So for number 2, we would measure to right about there and to right about there. So our RF value would be the distance of the dot divided by the total distance of the solvent. So for number 2, that distance to the dot from the baseline was 4.35 centimeters. For the purple dot, So our value is 4.35 divided by, what did we say our total distance was? 6.35. So it would be this distance divided by the total distance of the solvent line. And then the other dot for number 2, we'd measure in the center of the darkest spot, which would be right about here. We'd mark that with a pencil. This is all once the papers have dried. And again, the RF value would be the distance of the dot, measure the darkest center, the darkest spot. This was 5.9, and then divided by, what do we say, 6.35. So the R values will always be less than 1 because the total distance is always going to be on the denominator. So follow the lab instructions. You're going to measure R values for water for 1, 2, 3, and 4. Identical 1, 2, 3, and 4 for the R values for acetone. And you can see from our acetone that the dots are different in terms of what was soluble and what was not in the acetone. And same procedure, you measure to the top of the total distance the solvent traveled in our denominator, and then pick the darkest part of the dot, measure that distance, and then get your RF value. So hopefully that's clear, and we'll go over this in class in terms of the procedure. And there's also a video that explains simple chromatography that we'll also cover. So hopefully that'll help, and we'll see you in class. Thanks.